Good morning, guys. Just let's wait for 1 2 minutes and we'll start. Uh, in such kind of course like cellular biophysics and all, I think students have enrolled a lot, but the strength is very less. So, just we'll start with a quick introduction. Just let me share my screen first. Okay, so I'm Nitesh. Basically, I'm a PM or a fellow, as you all are aware of, at Department of Biotechnology at Hyderabad. Uh, Currently, I'm working on cellular biophysics lab. We are basically working with single molecule imaging where we quantify various biophysical parameters of different biomolecules inside the live cells. Okay, so we'll start with your this week assignments, that is previous year assignments basically. But this course or this weekly session will be basically focused on your discussion regarding what previous year questions people have faced, and based on that, what uh, the weekly theory that you have gone through, whatever doubts you have, or anything that you would like to discuss regarding those topics. So before going to that, just would like to ask you guys, so how many of you are from biophysics background or physics background, or all are from biologist? Okay, so Akshara is from physics, and rest are hope you are from you're pure biologist. But basically, the thing is like it's quite interdisciplinary these days. Like I personally pursued my MSc from zoology background, and even it's like that. So when we understand, like if you have gone through the courses like this week work, like week 1 courses and assignments, so this is basically an interdisciplinary thing. Like suppose you are, I was seeing your courses, and I find there are several things like starting from several biological phenomena that so it's not like it's pure biology, right? Suppose something is happening, like suppose there is a very beautiful examples of camouflage, right? Camouflage is happening, but it's a biological process, but there are so many aspects of chemistry and physics to understand that why it is happening and how it is happening. It's relevant to the cellular biology. If you have seen your slides or seen your lectures, uh, you must have aware about the various movements, even the blood flow, blood pressure maintenance, all these buffer system maintenance are basically a biological processes that is maintaining because of several physical and chemical aspects that is very much associated with all these things. Uh, I have shared you with my entire screen, so I'll show you some uh, of my movies that we have captured, and how basically in live cells how it looks. So just a minute. So here I'm sharing one of images. If you can see the live image of human cells. This is basically a breast cancer cell line MCF7, and here if you'll see, okay, let me just turn it. Okay, so here if you can see, the molecules are basically moving inside, right? This is a live cells imaging that we have captured from MCF7 cell lines. Basically, it's a breast cancer cell line. So if you'll see, the molecules are very dynamics. This is histones. Okay. So you all know histones are very stable molecules, and if you see the movement of histones, and these are very dynamics, right? These are based on different their localization from frame to frame. Basically, here we are capturing images from frame to frame, and based on the tracking, or based on associating particles from one frame to others, what we can see, we can see the different how these are associated from frame to frame, and based on that we can decode like whether the molecule is stable, unstable, whether it is diffusing, whether it is moving or not moving, right? So all these are basically biophysical parameters. Similarly, if you have seen the macrophages that is engulfing another macrophages or neutrophils, right, or very the immune cells that is engulfing, so they have different movement. Even if you see the different cells like sperms and all, they have flagella. The movement of flagella and all these are very much associated with biology, that is very much associated with this different physical parameters or properties, right? So these are what about introduction about your biophysics, and that's what we need to understand in biophysics. That we also need to study all these things, because of this you can get into different things, right? Suppose how you can associate it with this. Suppose there is a molecule and there is a target site for it, right? It is going to bind now, or then it is a question like why it is binding to that particular site, right? So this particular this protein or this molecule must have a particular chemistry. uh, I'll just show you one protein, like here if it is, you can see. So this is one protein basically. This is uh, just let it study like this is a protein. So you will see there are different sides of it, right? And it has several sites, like it has a particular active site, it has a particular binding sites that binds to a particular domain, right? So basically, if you'll see the structure of this particular molecule, it has several sites, several particular sites that is very much associated to get into bind it to its respective regions, right? So these are basically defined by different biophysical properties, different chemical properties, different structural configuration, and that defines its function, right? So basically we'll go through one by one different things. So but we just introducing you with this, I would like to go through your assignment questions, right? So because the main purpose of this to discuss different question, and based on that, what the theoretical aspects that we can cover, right? So here, if you see, the question is like Carter-Jenner syndrome describes which defects in human body plans, right? So how many of you are aware about this Carter-Jenner syndrome? So let me discuss about this. So this is basically a syndrome that is mainly occur in this is basically a syndrome. Primarily it's a because of the infertility, or this is also called like primary cilia dykinesis, okay, or it is called immotile cilia. So if you see the structure of your cilia, so it's like this, right? You'll find there are several tubulins, right, microtubules you can say, right? And basically, along with these microtubules, you'll find there are different proteins, right? So here, if you'll see, these are your dynation. Okay. Now there is a linker in between these proteins that construct this primary cilia. If you are from biology background, you must are aware about these things, right? And apart from this, there are two central cilia, or central microtubule. Basically, this is called core microtubule. Okay, these are bound. Now, in the structure, this is basically what the architecture, internal architecture. Suppose if I'll just consider one general structure of any biological organs having cilia, right? This is a sperm structure. If you'll see, several other examples, like if you consider, your abdomen or your various, pulmonary vesicles, you will find cilia structures like this that basically help in guiding of the food and air trafficking, right? So in the difference, or in the malformation of the cilia is basically responsible for this immotility of the structure, that is your flagella, right? And if the sperm flagella is immotile, this fertilization results in several defective embryos. And one major uh, deformalities they forms is called, that is basically called your dextrocardia. Okay, so in dextrocardia, this is a basically this phenomenon or this metabolism is basically responsible or relevant to one of the very much, I will say, pulmonary diseases, right? So if you see your lung structure, it is like this, right? So I'll just draw one. So this is just like this. Okay, and now if you see the structure of your heart, this is basically, I'll just put some other color. So if you'll see your heart, so this your heart structure is just like this, right? Here in this area. So it is basically where heart is present. It is basically present in the left side. So because of this malformation and the cilia structure and this abnormality that causes the diseases, this shifting, this presence of heart in the left side, that you in usual condition where it is present in left, is basically found in such patient in the right side. Okay, so the heart structure get changes from left to right. Okay, so this is a major condition of this malformation of organ transformation, organ translocation from one position to a different position. Okay, so coming to the just summary of this particular slide is that this diseases, that is Cattinger syndrome, is basically a disease because of the ciliary malformation. The normal cilia structure possesses this 9 plus 2 configurations arrangement with cilia and microtubules, where it have normal dynein arms, and it forms the entire ring structure with the with various, it needs energy for its various movement, its function. So all these are carried out by the ATP metabolism. So the problem with the immotile ciliary syndrome is an because of this absence of dynein arms, because of this no because of this arm, the cilia cannot move. So that results in the malformation of the cilia, that results in the diseases. So therefore, the places that have cilia which are not moving will be affected. Okay. So there are different conditions or different things that can possible because of this, because cilia is a core component of several things like sinuses, macrociliary escalator, sperms, fallopian tube, all these things. So if the cilia unsformed get malformed, it will lead to malformation of fertility, that is called infertility. Similarly, if it is in fallopian tube, the ovary cannot get into the particular position at particular time, results in the infertility of the female, right? Similarly, if you see, just a minute. Okay, so similarly, we'll see the major reasons what happened with this is the malformation or transformation of heart. This is called your dextrocardia. Okay, so there is no transportation of blood vessels. This is called situs. This is different conditions, but in heart diseases, or this dextrocardia is very much critical in case of primary ciliary diagnosis or immotile ciliary syndrome. That is basically called Cartigener's syndrome. So now if we come to the questions that we have, so Cartigener's syndrome describes the which defects in human body plans. So the left right location of the left right location of some of the organs, that is for sure, because the heart position is basically changed. The randomization of organ position along the axis of bilateral symmetry, lack of blood flow, impairment of the heart. So basically the option one would be correct because the left location of your heart is basically translocated to the right part. So okay, so this is basically a part of your Gardner syndrome. Now coming to the second question, in a typical ball drop viscometer experiment, which forces are not acting on the ball that plays a role in its movement. So if you have gone through your weekly experiments or weekly lessons that you have seen, so this is a figure of your uh, ball viscometer. So what basically the basic principle in this is, I'll just, it's not that tricky, it's very easy, right? Suppose you have taken this as a beaker or this is a measuring cylinder, right? So now you just drop a ball from the up. So this ball is your red color, right? So just, so when I'm putting a ball and there is a liquid here inside this container, then this ball, the dropping of this ball is straight. So this is basically connected with some transmitter that will give you the reading of this viscosity. What is the viscosity of this fluid? So what are the things that basically matters here, right? So when you drop a ball, basically the basic things that matters is the what is the weight of this ball or what is the material that it is made of, or what is the density, right? The second thing that matters is the what is the viscosity of this fluid that we drop in, right? Suppose it is a oil, it is more viscous. If it is a water, it is less viscous, and based on different fluids, right? So when you put this ball inside this, uh, measuring cylinder with fill of liquid, or you will get a reading in this viscometer. So this is basically called a ball drop viscometer. So where you put a drop and that reads the basically your viscosity of the fluid or liquid. Now, if you see the question, so just let's go to the question. So if you go to the question, it is that the typical ball drop viscometer experiment, which forces are not acting on the ball that play a role in its movement. Now, if you are dropping a ball, definitely it is coming through because of the gravitational force. So G is acting, right? When you are dropping a force, G is acting. The viscous drag, because of you are putting the ball inside the fluid, the viscosity is acting from the fluid towards the ball. So viscosity is there. Then buoyancy is there or not? Yeah, buoyancy is always there because when you are putting a solid ball inside a liquid, it impacts some buoyancy that tends to make this ball floating, right? So it will definitely act on it. But the option that is your magnetic, there is nothing to deal with magnetism, right? So this will be your option answer. So in a typical ball drop viscometer experiments, magnetic force is basically not acting, but the gravitational viscous drag and buoyancy is basically acting. So if you just uh, get into a bit more details, so if you'll see, so your gravitational force will act on this direction, right? Because you are putting this is your G, and the buoyancy and viscosity are basically in the opposite direction. That is from the fluid towards the ball that is not letting the ball drop, and the gravitational force is the force basically because of which the ball is tends to move towards downwards. Okay. Now coming to the next question, which relation between two thermodynamic variables distinguish liquids from fluids from the following list? Okay, so which relation between two thermodynamic variables distinguish liquid from fluids? Now, uh, any idea? Just let me ask you guys one question. Tell me, what is basically liquid and fluid? Any of you? Okay. So basically, uh, it's just like if you'll see generally there are three states of matter, right? That is solid, liquid, and gases. But fluid is something that can flow. Okay, so solid cannot flow, but the liquid and gases can flow. So basically, liquid and gases both comes under fluid. Now, uh, which of these parameters or which of these uh, things that is written here, which are these dynamic properties are basically responsible or related to this, that is your uh, fluid nature, right? So if you see that fluid is something that can flow in two conditions. So first of all, it generally flows, okay, and second of all, when you put some force, okay, when you put some force, let me some tangential force, so it will deform, okay, so basically it will deform, right? So liquid is something based on it can flow, and when we apply some force it will deform. When it put in some container it will take its property because its molecules are very free, they are flexible. So when we put in some proper container, basically it takes the area of that container, and this is very basics chemistry that we are talking about, right? So okay, so basically fluids can take the shape of the container, it flow, and it can deform under the any force, right? So now if you see, there are taking one after another pressure volume interrelationship. Like see, if there are more pressure, the volume will compress, fluid can compress, right? Similarly, even if it is liquid or if it is gas, fluid can have this pressure and volume interrelationship, okay? If you put pressure, the volume will decrease. If you see temperature pressure relation, definitely it will also happen, because if you increase the temperature, the pressure will increase, okay? Similarly, if you see to compressibility, both can compressible, liquids and fluids, right? So these can be also a properties that can differentiate between liquid and fluid. Liquid is compressible, but no, it has a certain limits, it cannot be compressible after a limit. But fluid, since gases are also fluids, you can compress that also, right? Similarly, temperature volume relation, if pressure can, there is one PV is equal to nRT. You better know what loss it is, I forgot, but so pressure and volume are very interrelation. There are, if temperature is increasing, if pressure is increasing, then volume will also increase, may also increase. It's not like it will increase. So basically, all these properties are relevant to liquids and fluids. So based on this, we can distinguish fluids and liquids. So all these are correct options. So make sure when you will give your exams, like in an NPTEL also, multiple options can correct. So make sure be prepared on that. That you have to be aware about every options. It's not like that every time you'll get one option correct. Okay, multiple options generally get corrected in NPTEL exams, so one or two or even three. So just to be prepared on that aspects. Now two cones made of the same material, paper of identical thickness, but of different cone radius are dropped. Uh, they arrive at the same time because of what? Now this is a basic simple cone experiment or ball experiment or whatever. You can just put something from a height, and the question is that whether it is reaching at the same time or not. So yes, it will reach in the same time. Now why? Because you are just putting two different cones with the same material but having two different thickness. Oh, sorry, two different radius. Like one cone is bigger and one cone is shorter. Still, if you see both of our, what are the force that is acting on both of these cones? So basically, both of these cones are basically getting or drop, and the only force that is acting on it are gravitational force, okay? Now if you see, the acceleration will differ, okay, the acceleration will differ, but still if you see the what are the things, or what are why, if they arrive in the same time, okay, now what are the conditions? Now if you see a concept, there is one concept of air and vacuum. If it is there as air is present, that you will put some resistance to both, and in case I'll ask like both are of different material, then it is also a parameter, or it is also a thing that can impact whether which one is fall earlier. Like suppose I will tell, I will drop a water drop and I will put a stone. Now in that case, it's also depend on the air resistance, right? But here if you see, both of the cone are made up of same material. Okay, and it is written that they reaches at the same time. Now what may be the reason? Now if you see, the terminal velocity of the two cones are different, but drag balance it out, the terminal velocity cannot be different. If it is different, then both will reaches at different times. But our conclusion is that both are reaching at same time, right? Now the second option is that drag and weight of the cones are approximately equal. Now if you see, what is drag and what is weight? Weight is basically mass into gravitational force, that is mg. W is equal to mg, right? Now drag is something external force if it is applied to that along with your mg, right? But here in both the condition, you are dropping at from a particular location and no external force is applied. So in that condition, the drag and weight are same, and that may be a reason that it is reaching at the same time. Okay, if the drag and weight are different, suppose I am throwing one and suppose I am dropping one, in that case it will different, right? In the only condition both will reach at the same time, they are balancing it out. But here what we are doing, the drag and weight are same, okay, because of no external force is applied, and that may be a reason that both are reaching at the same time. And the third option is the velocity is the square root of gravitational acceleration times area density of the paper divided by the density. Yeah, so this option is, I think, you can go, just it is correct, because the formula that uh, for this is your, velocity is equal to square root of that acceleration by density, right? Matlab, gravitational area density divided by density, that is, if you're ever about square root of 2 gm divided by r. So the velocity is directly proportional to the square root of gravitational acceleration. So this is uh, maybe a reason. And the fourth option, that the two cones do not arrive at the same time based on the dimensional analysis, it cannot be true, because it is written that they arrive at the same time because of what? So if they are arriving at the same time, so we have to find a reason for that. It's not like that we can say, but it is, yeah, it is possible. If it is not possible, then you can go for this option that these two cones cannot arrive at the same time. Okay. uh, Now coming to the last question. So if you see the question, I'll just in an experimental, if you have gone through your weekly session, it is mainly, this question is very direct. So you can just take the screenshot of this page. I'll just discuss this question, but I'll not solve this question. I expect you guys to solve and come in next class and we can discuss. But I'll just put forward all what it is asking. So an experiment to estimate the shear viscosity of vegetable oil is performed using ball drop viscometer. So basically, as I discussed, it is a ball drop viscometer where you put a ball from the top and the cylinder, and at a fixed temperature, that is 27 degrees, so there is no variables. Now here what you have, what are the things that are given? The average terminal velocity is given, that is your uh 0 point, sorry, just let me write. So here the terminal velocity that is given, sorry, terminal velocity of a 0.55 sorry, 5 millimeter diameter is observed to be okay. So basically the ball that we are putting, it has a diameter of 5 mm. Okay, so just let me write down the equation for you. The eta is equal to 2 divided by 9 del E g r square divided by terminal velocity. Okay. So basically, the eta is equal to 2 by 9 del E gr square by terminal velocity. So here, just I would like to discuss that the terminal velocity of a steel ball, that is 5 millimeter diameter. So first of all, when you are solving any question of such things, I think you all are experienced now. You have to convert it into one single unit. So basically, if you convert to SI unit, it will be easy because your options are in pascals, right? So here it is given that the steel ball, the diameter of the steel ball is 5 millimeter. Now what we are needing here, we are needing here radius, okay, and radius is basically your R. So what is the radius is basically diameter by 2. So if we will just divide by 2, that is 2.5 millimeter is your radius, okay. So and the terminal velocity is given 1.9 meter per second, okay. So bt is given, R is given, okay. 2 by 9 all are these are constants. The two more things, g, you know, this is 9.8 meters per second square, and the other thing is delhi. Now here if you see, given the density of the steel is 8.8 sorry 8 into 10 to the power 3 kg per meter cube, and the density of the oil is 918 kg per meter cube. So so delhi is basically the change in density. What is the density difference between these two objects? So delhi is basically uh, density of the object minus density of the fluid. So this is basically density of the steel minus density of the oil. And so it is very straightforward question that what is the value of dynamic viscosity eta. So it is, you just had to put all these values in this equation and solve it out and come to me that this is what we got, right? So 2 by 9 del is gr square by bt. It is basically in your tutorial 2. So you can just, if you are just have any confusion regarding this equation, you can go and see, and in case not, we can discuss on the upcoming classes, okay. So basically this is what for this week regarding your courses, regarding your week 1 thing. So if you have any doubts, just you can go ahead and let me know when you have gone through your courses. If you find any topic difficult, I think it is an introduction class, so I think first 2 3 lectures are basically deals with why you are going to study biophysics, and upcoming I think 2 3 you have this equation solving for your eta and viscosity and the difference between fluid and liquid and all these things what I've covered. So apart from this, if you have any doubt regarding this, just you can tell me. So I see your classes are from 7 to 9, but hardly any classes will go till 9, okay. So okay, uh, that's what I'm telling, to join earlier. So just come at 7, we'll finish it by most probably 7:38, okay. Because gradually we might face lengthier question and we'll solve it, so it will take time. But at this stage for this class, I think this is that's it from the assignment point of view and what I could put forward in terms of theory. Apart from this, if you need to discuss anything, you are feel free. Just I'm also a student currently working at IIT Hyderabad, so it's not to hesitate. You can just come with any idea, any questions that we can put forward and we can discuss. Any doubt, guys? Fine. Just try to join early. Okay. We'll start at 7 and we'll try to finish it ASAP. Okay. And we'll see based on what questions we have and how long it will take to discuss with you guys. So thank you guys. Try to join at right time. Okay. So that we can finish it in certain time. Apart from this, any question, any doubt in any week, you can just get back to me in my mail IDs, okay, and I'm always available for you guys to discuss. So that's what I can say. And you can again put queries in the nptel program, that discussion forum. uh, that's it from today. So thank you guys, thank you for joining. Nice to meet you all, and wish you continue forward for 8 more weeks, 7 more weeks, right? Okay guys, see you, huh? Thank you.